In this video, we're going to talk about Graham's law of diffusion and effusion. So first of all, let's talk about what the difference between the two is. All right, diffusion, if you see this little picture here, diffusion means just like a spreading out and a mixing of gases. So diffusion is just a mixture of gases. So say, for instance, if I squirted like some Febreze or perfume or something like that, and it mixes with the other gases in the air, that would be diffusion there. Effusion, on the other hand, is if I have a tiny opening. And you'll see in the picture here, if those gases are escaping through a tiny opening, that's what effusion is. Okay, say for instance that I poked a tiny hole in like a balloon or something. And so those gases are escaping through that tiny opening. And so that would be effusion. So it's important to know the difference between the two. Now, both of these, diffusion and effusion, these both depend on molar mass. All right, so these both depend on molar mass. So to kind of think about it, heavier things move slower, right? So if I have heavier particles and it's trying to mix with other gases, it's going to move a lot slower. So as your molar mass increases, your rate of diffusion or effusion actually decreases, because the whole idea of heavier things move slower. So the mixing of those gases, the rate of mixing or the rate of gas escaping through a tiny opening, that will decrease as the molar mass increases. And so there is an actual calculation that you might have to do with Graham's law of diffusion and effusion. And that equation is rate of gas 1, and that could be effusion or diffusion, divided by rate of gas 2 is equal to the square root of molar mass of gas 2 divided by the molar mass of gas 1. So here's where I've seen this here. You might see it on multiple choice. I think multiple choice is more of a conceptual kind of component. But in free response, you might have to either calculate the rate of one of them, or you'll have to find an unknown molar mass of another one. So all I do is you're basically setting up a proportion. The rate of the first gas divided by the rate of the second gas is equal to the square root, and you put molar mass of gas 2 on top and molar mass of gas 1. This whole idea of having your rate and your molar mass on opposite sides is because of the fact that molar mass and diffusion and effusion's rate are directly and indirectly related to one another. So that's why you see it mixed like that. So you could basically have 3 pieces out of the 4 and solve for an unknown if you have to use this equation. And so the big idea here is just knowing this relationship. And every now and then they have you calculate a rate or a molar mass accordingly. Now, where I've seen most of the questions in molar mass is they'll have a picture like this. And so what I have on this end is a cotton ball, and it has been soaked in ammonia, which is NH3. On this end, the cotton ball has been soaked with HCl. And so what's happening here is you have HCl gas that's traveling in the tube, and you have ammonia, NH3 gas, that is also traveling down the tube. Now, when these two things mix, they react with one another. So a reaction is NH3 plus HCl yields NH4Cl. And so the name of this is ammonium chloride. Now, ammonium chloride is a solid that is produced. And when that solid is produced, it's like a white kind of ring that ends up showing up in the tube. Now, you might say, oh, okay, well, I've got 2 gases. Basically, they're going to meet in the middle, and that's where they're going to react. But that's not the case. If you look here, you'll actually see that that white ring, that white solid that's produced, is here. It's not directly in the center. It's actually closer to the HCl side. And you might have to justify why this is the case, or you might have to predict where the ring will form, or something like that. So why is it that this ring, this solid, will form closer to the HCl? Well, it all has to deal with this idea here. If I find the molar mass of HCl, it's around 36 grams per mole. The molar mass of NH3 is around 17 grams per mole. Ammonia has a smaller molar mass than HCl. So since my molar mass of HCl is greater, my rate of diffusion is smaller. So that means that basically this gas here isn't going to travel as far, as fast as the NH3 gas. This is lighter, so it's going to travel farther. And that's why these two gases mix and react closer to the HCl, because the HCl has a greater molar mass. They can put twists on this problem. They can say, oh, okay, well, what gases do I need to put on both ends in order to have my ring form at the middle? So you might have to compare, we want two gases that are equal to the same mass if they want to meet closer to the middle. It might say, well, my ring meets over here. What needs to be on this side, HCl or NH3 or something like that. So they can put a lot of twists on this type of multiple choice question. The biggest thing is just to realize this relationship, molar mass and the rate of diffusion or effusion. And if you can understand that, you can answer those multiple choice questions pretty easily. So this is on Graham's law of diffusion and effusion, and I hope it helps you get some multiple choice credit.